Okay, let's untack this. Today we're diving into something that can feel really complex. The core architecture of a big business intelligence platform.
Right, and our roadmap for this is a bit unusual.
It is. We're not using a white paper. We're actually using a certification study guide, the HCE-5910.
And that's a brilliant way to do it. A certification guide isn't just a list of facts, it's a blueprint.
A blueprint, exactly. It tells you what's mission critical.
If it's on the exam, it means the platform literally cannot function without it. It cuts through all the marketing fluff.
So our mission today is to walk through the 6 main sections in this guide. We'll go from installation to data to reporting, all the way to maintenance. We're going to figure out what really makes a BI platform tick.
And we have to start at the very beginning, how it connects to the data.
Absolutely. The foundation.
When you look at the source material, the absolute bedrock technology for connecting to any kind of relational database is JDBC.
JDBC. Java Database Connectivity, that's been around for a long time.
A very long time.
So why is it still the standard? And, why is the Java part so important for a big BI suite?
It's all about standardization and portability. The platform has to be database agnostic.
You can't care if you're using Oracle or something else.
Exactly. It doesn't matter if it's Oracle, MySQL, Postgres, whatever. JDBC provides that uniform interface so the BI server can just send out standard SQL and get results back.
Okay, so it's like a universal translator.
That's a perfect analogy. The platform speaks JDBC, and then the specific driver translates that for the database.
Which means your reports and models will work the same even if you swap out the database underneath.
Precisely.
All right, so we've used JDBC to pull in the raw data. Now we have to shape it for analysis. We're getting into OLAP territory here, right? Online analytical processing.
We are. And the tool for that, for designing that multi-dimensional structure, is the Pentaho Schema Workbench.
The Schema Workbench. And this is a really critical architectural question. What does that workbench actually produce? What's the file, the artifact that it spits out?
Its main output is a structured XML schema.
An XML file.
Yep. And that XML file is basically the detailed instruction set for the analysis engine. It defines everything, the OLAP cubes, the dimensions.
So things like customers, products, time.
Right. And the hierarchies within those dimensions. Like a product line, which drills down to a product category, then down to an individual SKU.
And the measures, I assume.
Yeah.
The numbers.
And, of course, the measures. The values you actually want to aggregate, like profit or units sold.
Using XML sounds, well, a bit rigid. I mean, if we step back and look at the big picture, isn't that a huge commitment? Once you define a hierarchy in that file, you're kind of locked in, aren't you?
You are. That's the trade-off. It's rigid, but it's also highly performant because it's rigidly defined. It's optimized for that kind of querying. But yeah, it requires real governance. If your business decides to add a new level to a hierarchy, you have to go back, update that XML schema, and then redeploy it.
So you're trading flexibility for speed and predictability.
You're trading on-the-fly flexibility for incredible query speed. It's a classic architectural choice.
That makes a ton of sense. Okay, so we've got the technical plumbing sorted, we have the JDBC connection and this XML structure, but the end user, the business analyst, they don't care about XML.
Not at all.
They just want to see quarterly revenue, not some database column named FCTT45QTRR. So how do we bridge that gap?
This is where the magic happens. This is where you use the Pentaho metadata editor.
The metadata editor. And its job is to create the semantic layer.
Yes. And that is probably the most fundamental concept for user adoption in all of BI.
Why is it so non-negotiable? What is that layer actually doing for the user?
It's an abstraction bridge. It takes all those ugly, complex physical data details, the weird column names, the table join logic, and it maps them to plain, business-friendly words.
So it's a dictionary. In a way.
It's more than a dictionary. It lets users interact with concepts, not code. They can drag North American sales onto a report canvas. They don't have to write a 20-line SQL query joining 4 tables to get it.
And that's what makes self-service BI possible.
It's the only thing that makes it possible. If your semantic layer is wimped, your business users will just give up and go back to spreadsheets, period.
Right. So the entire success of the platform really hinges on hiding all that technical complexity behind a simple layer of language.
Absolutely.
Okay, we've handled the back office work. Let's move to the front end, where the users actually live. We're talking about the Pentaho user console, or the PUC.
The PUC, right. The control center for everything.
And if it's a control center, security has to be job one. The sources are really clear on this. What are the required components for controlling access?
It boils down to 2 things, and only 2 things. Users and roles.
Users and roles. That seems straightforward, but what's the architectural reason for keeping identity of the user totally separate from permissions, the role?
It's all about scalability. And the principle of least privilege. A user is just an identity. It's John Smith logging in. A role is a set of permissions. It's executive or sales analyst.
And you don't give permissions directly to John Smith?
Never. You grant permissions to the sales analyst role, and then you just assign John to that role.
Why is that so critical in the real world?
Well, imagine you have 500 sales analysts. If you had to manage folder access for each of those 500 people individually, it would be an absolute nightmare.
A maintenance disaster.
Total disaster. But with roles, you just update the permissions for the sales analyst role one time, and all 500 users inherit that change instantly. It's the only way to manage security at scale.
Plus, the sources point out that other things, like your browser type or IP address, are explicitly not used for access control.
Right, because those are transient. They're not stable. Security has to be based on identity and function.
So what this all means for you, the user, is that security scales only when you separate who you are, the user, from what you can do, the role.
Exactly.
Let's shift to visualization. We'll start with those structured, formal reports you create with the Pentaho Report Designer. We're not talking about interactive dashboards yet.
No, these are formal documents, things that might go to a regulator or a board of directors.
And for something like that, consistency is everything. So what's the key feature the source material highlights for making sure reports look the same everywhere?
The term they use is pixel-perfect formatting.
Pixel-perfect. I like how specific that sounds. Why do you need to go to that extreme?
It's for any document that has to meet a strict standard. Think corporate branding or legal filings. If you're sending a quarterly financial statement out as a PDF, the logo has to be in the exact right spot, the margins have to be precise.
The font size can't be off by a single point.
Not at all. Pixel-perfect formatting guarantees that the report will look identical whether you view it on a screen or print it on paper. It removes any and all ambiguity from the visual layout.
Okay, so inside this highly controlled report, what can we actually embed? What components are valid?
You can embed two main things: charts for obvious data visualization and subreports.
Subreports. What's the use case for those?
They're really important for structure. You might have a high-level summary report and then embed a subreport inside it that shows a very, very detailed list of transactions for a specific category. It lets you combine different levels of detail in one document.
Okay, now for the fun part. This is where it gets really interesting. We're jumping from those static documents to dynamic interactive dashboards in the Pentaho Dashboard Designer.
Right.
How do you make two different things on the screen, say a chart and a table, talk to each other?
The mechanism for that is called content linking.
Content linking.
And this is what transforms a dashboard from just a collection of widgets into a single, coordinated analytical tool.
Walk me through a clear example of that.
Okay, imagine you have a pie chart showing sales by region. Next to it, you have a big table with every single transaction.
Okay, got it.
With content linking, when you click on the West Coast slice of that pie chart, the transaction table instantly filters itself to show only sales from the West Coast.
Ah, so the action in one place drives a change in the other?
Exactly. It creates this coordinated, drillable view that lets you explore the data in real time just by clicking around. It's a fundamentally different user experience. You're not just looking at numbers anymore, you're interacting with them.
That's a huge shift. Now let's talk logistics. What if I want to automate this? Schedule a report to run every morning at 8 a.m. Where does the final output file go?
So when you schedule a report, the output has to be stored in a governed central location. The only valid destination mentioned in the sources is a specific folder within the repository.
Repository, why there?
It ensures that everything is managed, you have centralized access, proper version control, and all the security roles we just talked about are applied consistently. You don't want reports just being emailed out into the wild.
Makes sense. Keep it all in a managed space.
Right.
Okay, let's switch gears one more time. If the report designer is for presentation, what's the tool for pure exploration? That brings us to the Pentaho Analyzer.
The Analyzer tool, yeah, this is built for the business user who just needs answers, fast. They don't have time to design a perfect layout.
So what are its core capabilities?
Two main things stand out. Drag and drop report creation, which is all about ad hoc, on-the-fly analysis, and crucially, the ability to drill down into data hierarchies.
And that drilling down is really the heart of multidimensional exploration, isn't it?
It's everything. It means you can start by looking at sales by year, then click on a year to see the quarters, click on a quarter to see the months, and so on, all the way down to a specific day or transaction.
Without writing any code.
Without writing a single line of code, it lets users slice and dice the data from any angle, following their curiosity. It is pure interactive discovery.
This brings us to the final and maybe the most critical piece of the puzzle. Performance. Maintenance and tuning.
Yep.
We've done all this work. We've defined the data, secured it, built beautiful reports. But if the data set is massive, billions of rows, and a report takes 5 minutes to load,
the whole system fails. Users will abandon it.
So what is the single most effective performance strategy our sources identify for tackling that sluggishness?
The #1 strategy, especially for OLAB, is using aggregate tables.
Aggregate tables. Now, if we connect this to the bigger picture, this is another one of those classic architectural trade-offs, right?
It absolutely is. Can you explain why aggregates give you such a massive performance boost?
Well, it's about doing the work ahead of time. You're pre-calculating the answers to common questions.
That's a great way to put it. So when a user asks for total sales by month, the system can either scan the entire massive transaction table with billions of rows,
Which takes forever.
or it can look at a much, much smaller aggregate table that already has that data pre-summarized at the month level.
So you're trading storage space to hold those extra tables for processing speed at query time.
Exactly. The aggregate tables store data at higher levels by day, by product line, by region. When a query comes in, the OLAP engine is smart enough to find the smallest, most efficient aggregate table that can satisfy the request.
And it avoids scanning the full detail table.
By avoiding that scan, you reduce the amount of data being processed by orders of magnitude. For big data analysis, it's not just a nice-to-have, it's essential.
So we've gone from the core plumbing of JDBC all the way up to pixel-perfect reports. You should now have a really solid grasp of what makes these platforms work.
And what's so fascinating when you look at it all together is how much of modern BI success relies not just on raw speed, but on really effective abstraction.
Abstraction, hiding the complexity.
Exactly. We spend all this time talking about schemas and tuning, but the ultimate goal, the marker of true architectural genius, is making sure all that complexity, the JDBC drivers, the XML, the aggregate tables, is completely invisible to the end user.
So they can just focus on their job.
So they can focus entirely on asking the right business questions. That's the whole point.